All right. So unlike our other vectors that you could just sort of move around wherever, as soon as you have a position vector, it's sort of fixed in place because the origin is fixed in place. And you can talk about any point anywhere on your grid as its position vector instead of as a point. So before we used to call, point, whatever point that is, 4, 3, we would think of that just as a point. But now we're going to think of it as a vector from the origin to that point. Yes?
Do you know for the gym hours, if we have to write them down for, if we have like, because on my workout I had like healthy living or something like that,
Yeah.
that means like...
I don't know anything about gym hours. You'll have to check with your... When is the last day to do your gym hours? You better find that out before 3:30.
Yeah, go on power school and if it says credit earned, well then you don't need to do anything. It doesn't have anything else in class.
Ooh.
Alright, well I might go for a quick bathroom break. Yep.
All right. See you in a bit. Okay.
Yeah, Connor needs help in that. Special areas.
So we got two position vectors, m and n. Here's the origin. M is some point over here, n is some point over there. Imagine that's the origin. And you want to write m to n in terms of the position vectors m and n. And this is going to connect to our adding and subtracting before. If I wanted to start at m, and I wanted to get to n, but I have to use my position vectors to get there, how could I do that? Well, I could go this way to O, negative m, so mn. I would first go negative m. That's a vector, so I'll put an arrow over top of it. And then I would add n to it. And that would be the same as getting from m to n. Part B, what about going backwards? N to m. Well, we could think the same way. I'm at n. I could go backwards along n and then add m. So we could go back to our diagram and think of it that way. The other thing you could think about is, does it make sense that n to m is exactly the same as negative m to n? Because it's just the same one in the opposite direction. So if we took our answer from A, and our answer from A was negative m plus n, and did a negative in front, and distributed that negative, you would see you would get exactly the same as we did negative n plus m. Now what's really cool about vectors is you can start to do some complicated mathematics with them and figure out complicated vectors and all sorts of things just by using position vectors. So I'm going to go back to our diagram. We're going to imagine we've got a point P, which is the midpoint from m to n. And you have to get there using only m's and n's. How would you do that? Right? If you were told you can start from here, you have to get to there, but you're only allowed to walk on lines that go this way or lines that go this way, what would you do? Well, you would start walking along here, right? And at a certain point you'd say, ooh, I am exactly this parallel to that one, that vector's direction away from P, and then I could turn and go that way for a certain. Now, how long do I have to walk along here, and how long do I have to walk along there to get to that point? Well, first of all, if P is the midpoint from m to n, does it make sense that if I would go halfway from m to n, I would get to P? Okay? So if I go halfway from M to N, that would be the same as going from M to P. And if I would want to go from O to P, because this is what we want to figure out, I could get from O to P if I started and went from O to M, and then went from M to P. So now let's see, can we write out all the information that we have just using M's and N's? Well, first of all, to go from O to M, we know that that's just vector M. And I just wrote above that M to P was halfway from M to N. So I can say halfway from M to N, and we figured out in part A that M to N was negative M plus N. Multiply that through and simplify, and you're going to get halfway to M plus halfway to N. And if we look back at our diagram and what I drew, does it kind of look like that's what we've done? We've gone halfway along vector M, then turned directions once we get to this point, and done this vector, which is vector N, but only half of it, and we get to P. Yeah, I'm just going to pause the video.